So this video is how to show you how to do a one sample t-test or hypothesis testing using the t-distribution with jamovi. So in our problem, we have 5 participants and we're interested in a mu of 15. And I actually have it here as well. Our alpha is going to be 0.05. That's important because we need to tell jamovi that. Here we have the raw score. So usually when we do this type of problems, we have the sample mean and the sample standard deviation. We can calculate those in jamovi for sure, or we could use the formulas. That would just take us a little longer, and we don't want to do that right now. But we can just take this data to jamovi. I just want to pay attention to the pair of hypotheses. So here we just want to see if there's a difference. If therapy has significantly affected anxiety levels, but they don't really tell us whether it's less or greater than. So we're going to go with two-tailed. Let's go into jamovi. So here's what the data would look like in jamovi. I have 2 columns. This one is just the ID. It has a little tag. We're not really going to use it. So this is just to tell us what participant had this score. Like if we had a data entry error or something like that, and we need to go back to the surveys, like the ID would help us. But that won't happen to us, don't worry. We have a treatment variable, which is its own column, and it is continuous because it has numbers in it. So it's definitely continuous. We're going to go into analysis, t-test. We're doing one sample t-test. That's what jamovi calls it. Your textbook calls it hypothesis testing for t-distribution. Same thing. We drag the dependent variable, which in this case is going to be the continuous variable, into the dependent variable box. Notice how it has the little continuous ruler here. So it wouldn't let you put the wrong variable here. I mean, if it was labeled as nominal or SID, it would just not let you do it. You leave a test as student. Here in hypothesis, what you need to put is the mu, which we discussed was 15. And notice how the statistic here is going to change when I hit enter. This also changed here. It was 0 before and now is 15. Remember, in the formula we do minus mu. So if we do minus 0 here, we don't change that value. It's going to give you a different test statistic. We decided we're going to use different, so I'm going to leave that one selected. You don't have to mess with missing values, at least not in this class. We're going to go here to additional statistics. I'm going to check mean difference, and it tells me what the mean difference is. But what I want is the confidence interval. So I'm going to click here for confidence interval. And that should be what the confidence interval is. But it's also actually set for 95%. And I actually want 99. So I need to change that. This is a common error. And it's going to change here in the table when I hit enter. Boom, and it actually changed the confidence interval, so that's interesting. You could also ask for descriptives. So if I actually wanted to calculate the test statistic, I could use, this is my sample mean, and this is my standard deviation. This is my sample size, and I know mu is 15, so I could calculate all of those, and I should get that 5.28. Finally, I am going to check whether I can use the t-distribution by checking the assumption of normality. So we have 2 options, but the only one that we cover in the class is the QQ plot, so I'm going to click that one. So remember, what we're looking for in the QQ plot is that we have a line at a 45-degree angle, and then the little dots which represent our data, and those are like standardized scores. You can think of them close to C-scores, very similar to that, but we want to see them close to the line, and it is pretty close. I mean, we do have this one value that's kind of out there, but they're pretty close, so I would say we meet the assumption of normality.